8.2 is about factoring by grouping, and we need to not forget what we learned in 8.1. We are still going to factor using the greatest common factor, but we are going to build on that in this section and see if after we factor using the greatest common factor, we can actually factor more, and that is the beginning of what this section is going to look at. So the first thing we're going to do is we're going to look at what happens if the greatest common factor is actually a binomial. And remember, a binomial is a polynomial that has two terms. So sometimes our greatest common factor isn't just a number or a monomial. The greatest common factor is a binomial. So if you look at example 1 here, you can see in this purplish color that both of these terms, and again, I can see the terms because they are separated by this plus sign, right? There's one term on the left and one term on the right. And what does each term have in common? Well, the thing that they have in common is this greatest common factor, which in this case, sort of oddly enough, is x plus 2. So I can take that greatest common factor out the same way that I did in the last section of notes. I can take x plus 2. I know that when I factor, I'm undistributing. So basically what I'm doing is I'm taking each of these terms and I'm dividing it by this x plus 2. And when I do that, this divides to be 1. So the only thing that's left here is 5. And when I do that over here, this divides to be 1. And the only thing that's left here is positive 3x. So the way that this works is really similar to how we did last class. But now that greatest common factor is a little trickier. It looks a little different. It's just a binomial instead of a monomial. So let's go ahead and look at number 2. And I did already in purple kind of identify this greatest common factor for you. So our greatest common factor in this case is this b squared plus 1. So that is what's going to come out in front, b squared plus 1. And I'm creating parentheses when I factor. I'm undistributing. So if I divided this by b squared plus 1, those are going to divide to be 1, and what's left over? My negative 2b. If I divided this by b squared plus 1, what's left over is just 1. If I divide anything by itself, what's left over is 1. So I have b squared minus 1 times the quantity negative 2b plus 1. So let's look at a couple more examples where that binomial is easy to identify. So go ahead and look at number 1 that we do and see if you can highlight or underline what that greatest common factor is, or even just state what that greatest common factor is. So that greatest common factor here is s plus 6, and you can see that each of the terms has it right here. So when I factor out this greatest common factor, s plus 6 is going to come out to the front. I'm creating parentheses, so if I divide this term by s plus 6, what is left over? My 4s. And if I look at the second term and I divide out that s plus 6, if that divides out, what's left over here is negative 5. So this expression is equivalent to s plus 6 times 4s minus 5. Why don't you go ahead and pause the video, identify that greatest common factor on number 2, and then see if you can factor it out. So that greatest common factor is 2x plus 3. So I'm going to divide each term by 2x plus 3, and I'm going to pull the 2x plus 3 to the front. So if you got there, go ahead and pause the video and see if you can keep working through it. So if I divide that first term by 2x plus 3, I get 7x. If I divide that second term by 2x plus 3, I get 1. So please check and be careful. I'm going to put a caution sign here. Be careful. There needs to be something here, because if I distribute this back out, I need to get 2x plus 3 times 7x, and I need to get 2x plus 3 times 1. So don't leave off your term. Be really, really careful. If there were 2 terms to begin with in your second set of parentheses, there should still be 2 terms. And part of you might be thinking, well, this is a very special type of problem where we can already see that binomial at the beginning. But what happens if that binomial isn't there? There's got to be more, right? I've got to push you a little bit harder. And there is. So let's talk about that next. What happens if there isn't a binomial expression that you can see right away? And if you look at this example here, example 3, right up here, there isn't two binomials. What I see right now are four separate terms. And again, I can see that there are four terms because there are 3 plus signs, and in between each of the plus signs is a term. So I'm going to walk you through the process of how you can factor out the greatest common factor, or factor out that binomial, or actually get to the point where we can see what that binomial is. And this method is the factor by grouping method. So notice there are 4 terms, and that is usually the big indicator to me that I'm going to try out factor by grouping, is when I see 4 terms. What you're going to do is you're going to group the first 2 terms together, and you're going to group the second 2 terms together. Make sure, and I did not do a very good job of this right now, make sure that you leave that plus sign between them. Otherwise, you're actually changing the problem, and we don't want to change the problem. If you put parentheses here, this becomes multiplication. It's not multiplication. So we want one set of parentheses plus the other set of parentheses. And that's kind of what I mentioned right here. Make sure you keep the addition symbol between them. Now that you have done that, you're actually going to identify the greatest common factor for each set of parentheses that you just created. So looking at, I'm going to use a different color, looking at this first set, x squared plus 3x. What's the greatest common factor there? Well, that's going to be x. And what do I get if I factor out that x? I get x plus 3. Keeping that plus sign in between. If I look at my second set of parentheses, 4x plus 12, what's my greatest common factor there? Well, 4x plus 12, they're both divisible by 4. And what's left over if I factor that out? X plus 3. Here's my favorite part of these problems. At this point, you should know that you're right, and you should know this method is going to work if these 2 things match. And when those match, and you're going to think I'm silly, but you already do, you need to self 5. Did you hear that? Give yourself a high five, because you're right so far. It matches. I expect that right now you're self-fiving. You're clapping with yourself. And now we have gotten back to the point that we were already at up here, where we just need to factor this out. So this is what they have in common, and that is in this step down here, sorry. So that's going to factor out to the front. And when we factor that out, when we divide by x plus 3 for each term, what's left over? This x is going to go here, and this 3 is going, oops, not the 3, and this 4 out front is going to go here. So just like we did on the top. So step 1, notice that there's, well, actually step 1, always check for a greatest common factor first. Step 2, if there's 4 terms, add parentheses around the first 2 and parentheses around the second 2. Be careful to make sure you keep the plus sign in between them. Then find the greatest common factor for each set of parentheses you created. Hopefully that matches, so you can self 5. And then factor the remaining expression. So we're just going to do 3 more examples, and then that's going to wrap up 8.2. So looking at number 3 down here, I'm going to check first greatest common factor. And I will be honest with you, I forget this a lot, and it makes my life harder. And when I look at this, I do actually see a greatest common factor here. I see that everything here is divisible by 2. So what does that mean? We haven't seen something like this before. It means I'm going to, before I do anything, I'm going to divide each term by 2. And what is that going to look like? At the very end of my question, I'm going to have a 2, or at the very end of my work, I'm going to have a 2 in front of these sets of parentheses. So that's going to leave me with 3h to the 4th minus 4, nope, not 4, minus 2, if I divided by 2, 2h to the 3rd plus 6h minus 4. Now that I took out my greatest common factor, I'm going to put parentheses around my first 2 and parentheses around my second 2, and I'm going to keep that plus sign in between them. I'm going to identify the greatest common factor here, which looks like h to the 3rd. So I'm going to factor h to the 3rd out. That leaves me with 3h minus 2. I'm going to look at the greatest common factor here, which looks like 2. So plus 2, if I factor that out, 3h minus 2. Right now, giant self-fiving should be happening. You should be super excited, and you should be excited because these 2 things match. Self-5, go us. We are so far right, and that thing that that factor that we just self-5'd over, that expression is going to factor out. And what's left over when we factor that out? What have we not used yet? Well, we factored, and that leaves us with h to the third here if we divided 3h minus 2 out. And it leaves us with 2 here if we divided 3h minus 2 out. So our final answer, I'm going to rewrite this so that you can see it a little bit better. 2 from the very beginning that we factored out times 3h minus 2 times h to the third power plus 2. All right, looking at number 4, I'm checking at the very beginning, is there a greatest common factor that goes into everything? And the greatest common factor here is 1, so there's nothing that we need to worry about here. Nothing else can be factored out. So 4 terms, I'm going to group the first 2 together. Do you see how this negative sign is in between? That negative sign is stuck with my y. So I'm going to put a plus, or actually I'm going to turn that negative into a plus. And I'm going to rewrite this negative inside. So there's a plus in between my 2 sets of parentheses. That negative sign needs to stay with my y. I can't just take it out in front of parentheses. That changes the problem. So I'm going to identify the greatest common factor here. That's going to be 5y squared. So if I take 5y squared out, that's going to leave me with y minus 3. The greatest common factor here, if you remember in the last section, I said anytime that first term, so this is plus negative y plus 3. Anytime that first term is negative, we want to take that negative out. So I'm going to take negative 1 out. That's going to leave me with y minus 3. Right now, we should be throwing a self-5ing celebration because these match. So I'm going to factor that out. That is my greatest common factor. And what's left after I factor that out, or if I divide this by y minus 3 and this by y minus 3, here that's going to leave me with 5y squared, and here that's going to leave me with minus 1. Why don't you go ahead and pause the video and work through that last problem on your own, and I'm going to rewrite it down on the bottom so I have a little bit more space to work with it. All right, I'm hoping you had the chance to start and work through that problem. Step 1. Check to see if there is a greatest common factor with all 4 terms. And there's not. Not with all 4. There's with 3, but not with 4. So step 2, add parentheses, make sure this plus stays in between. Identify the greatest common factor with the first set, which looks to be 2b squared. If I factored 2b squared out, that would leave me with 3b plus 4. And then with the second set of parentheses, that greatest common factor looks like it's going to be 3. So plus 3 times 3b plus 4, self-5. We know we're right because these match. So we're going to factor that out. That is our greatest common factor binomial now. And what's left over when we factor that out, when we divide each of these terms by 3b plus 4? Well, what's left in red is my 2b squared, and what's left in blue is my 3. So factoring out a binomial really builds on what we learned last class. Don't forget that every time you start a factoring problem, you should always check first to see if there's a greatest common factor besides one that can factor out. Then, if there's 4 terms, you're going to use this grouping method. You're going to add parentheses, making sure that you keep a plus sign in between your 2 sets of parentheses. You're going to factor out the greatest common factor for each individual set of parentheses, which should create a binomial that you can then factor out, and write your final answer as the factors being multiplied together, right? You're writing it as something that looks like a product that if you multiplied out would get you back to your original polynomial. So make sure to write down any questions you have, and I look forward to supporting you on this in class. Thanks for listening.